All right. This is POTD, 23rd of March 2026. All right. Maximum non-negative product in a matrix. You are given an m by n matrix grid. Initially, you are located in the top left, and in each step, you can move right or down. Okay. Among all the possible paths, starting from top left corner and ending in the bottom right, m-1, n-1, find the path with the maximum non-negative product. The product of a path is the product of all integers, and then modulo. If they return the maximum non-negative product mod of this, if the maximum product is negative, then return -1. So you do like a maximum between the product you get and -1. Find the modulo. What? Well, notice the modulo is performed after getting the maximum. Yeah, sure. It is not possible to get a non-negative product. Oh wow. Oh sure. Okay. So like, no matter where you go, 1, 2, 3, 4. Oh, yeah. So because you always have an odd number of cells in the path, I think. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wait, you can't go up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So we always be like 5. Here you can have like 8 by 1, get 8, and I guess that's the biggest one. Okay. And then, oh wow, 0, yeah, sure, 0, because any other way would be negative. So is it fair to say, so just observations wise, you're going, in order to get from top left to bottom right, you're always going to have to move, if there's n columns and m rows and n columns. I mean, I'll write this down actually, so that's clear. So this is 1594 POTD. So if you have m rows and n columns, to get from here to here, you're going to have to move, this many times across. I guess n-1 times across. And then m-1 units down. The order in which you move across and down will be different. But my point is the total number of cells that you're going to have to traverse is going to be, I think, m-1 plus n-1 plus 1. So where have I got that from? If I take the 3 by 3 example, I'm going to have to move 2 across and 2 down. No matter what path I take, I'm always going to have to go 2 across, 2 down. Like, this is 1 down, 1 across, 1 down, 1 across, right? Or 2 down, 2 across. Or like, across, down, across, down, across, down, down, across, down, down, across, you know what I mean? Like, you're always going to have to do 2 across, 2 down. So that's the m-1 and the n-1. And then the plus 1 is because to count for the extra, like for the original starting point. So total number of cells is going to be this many things. So which we can simplify to m plus n minus 1, right? So that's this many cells that you're going to have to find the product of. This is very similar, like this feels very similar to that DP problem, no? Where you are looking for, I forget exactly the problem, but it's like the number of ways you can get from top left to bottom right. I'm not sure if it's quite the same, because this is talking about product instead of number of ways to get from top left to bottom right. But if I do take that approach, if I imagine, like, if I take my smallest subproblem, my base case, to be just this value here, then what's the biggest product I could make? If I take this example, if my starting point was here, what's the biggest product? It'll just be 1, right? And then if I was to go up here, what's the biggest product I can make? It would be also 1. If my biggest product was, if I started here, what's the biggest product I can make? Well, it's -4 times 1, so -4. Maybe I would change that to -1 straight away. I'm not sure. So let me take this example. So what is it? 1, -2, 1, and then 1, negative, same thing. And then 3, negative 4, 1. So, you know, if I just sort of lean into this DP idea, it would be something like, you know, some kind of 2D thing. And at each cell, the question being asked is, if that cell was the starting point, what is the maximum product I can make, you know? So starting from down here, if this was my starting cell, what's my biggest product? Is 1, right? Because I would be here, I would finish here, that's it, 1. If my starting point was here, what would be my biggest product? Well, also just 1, right? It would be 1 times just that 1. If it was here, it'd be minus 4, maybe negative 1. Maybe I would change it straight away, I'm not sure. And then over here, what's my biggest product? Well, I can do minus 2 times, maybe I won't do the minus 1. Minus 2 times minus 4. Ooh, but this is interesting because I would rather keep the minus 4. Rather than, like, Okay, anyway. Minus 2 times minus 4 gives me 8. Minus 2... If I was to go this way, then the best product I can make is a 1. So it's minus 2 times 1 makes minus 2. So the best thing I can make is 8. Interesting. I wonder if it's worth, like, keeping track of the most negative thing you can make and the most positive thing you can make. Like, the best positive number I can make is positive 8. The best the most negative number I can make is minus 2. The reason for that is, like, depending on if a certain value is positive or negative when I start, like this is a 1. So I would be looking for the positive version. So here, the most positive number I can make is a 1, right? The most negative number I can make is, well, I can't really make a negative number, so just none, I guess. You know what I mean? And like here, the most positive number I can make, that doesn't exist, so none. Most negative number I can make here is negative 4. Most positive number I can make is going down this way, multiplying the negative 2 by the most negative product here, making positive 8. The most negative number I can make is either minus 2, and that's it. So, I have the negative 2 written. And then over here, the most positive number I can make is none. I can't make a positive number. The most negative number I can make is negative 12. Over here, the most positive number I can make with a negative 2 would be 4. And this is why it's important to keep track of the negative 2 over here, right? Because negative 2 times the negative 2 made over here by going like this is positive 4. That's the best. But the biggest negative number I can make would be negative 16. Taking the positive 8 from here and multiplying it by the minus 2, which is going like this. Positive 8 times negative 2. And then for over here, the most positive number I can make would be 8. The most negative number I can make would be going down this way and taking negative 12. And here, the most positive number I can make is 8. The most negative number I can make is negative 16. And then for here, I would only want to take the positive number. And if that positive number is none, that indicates that I can't make any kind of positive number from over here, and therefore I should return negative 1. This would be my idea. So if I was to define the subproblem, Q of some particular row, some particular column is asking, assuming RC is the starting point, what is the most positive product I can make, and what is the most negative product I can make. And then as a base case, the Q of, so row m-1, right, because m rows, m-1, and column n-1 is equal to either x none if x, I shouldn't say x is greater than or equal to 0, or none x if x is less than 0, where x is equal to, we'll call, what was this thing called, grid or something? This original red thing is grid, where x is equal to grid m minus 1, n minus 1. So we'll make a deep, so to structure our data, we'll make a DP array, 2 by 2, same size as the original grid by n. But each element, what I would find in each element is a tuple that consists of the most positive and then the most negative. And hopefully, to solve any particular subproblem, Q of, let's say, some particular row, some particular column, look at, so to solve this, so consider the grid at that particular R and C. We'll call it Y, or we'll call it alpha, right? The value at RC, we'll call it alpha. So case 1 is if alpha is greater than or equal to 0, right? So like a positive number, then look right, sorry. You can go right and down, right? Yeah. Look right and look down. Find the bigger positive value. Find the bigger positive value beta and set the tuple that we're going to make to equal alpha beta set the tuple to equal alpha beta first, and then look right and look down. Find the more negative, so technically smaller, value gamma and set the tuple to equal alpha gamma. So then the overall tuple would look like alpha beta, alpha gamma, where beta is the most positive value between the bottom and right neighbor, and gamma is the more negative neighbor in the bottom and right neighbors. And then if alpha is less than, maybe I can do 3 cases. If alpha is strictly greater than 0, then do that. If alpha is less than 0, then do something else. Then basically swap it around. Look right and down for the more negative value gamma. Look right and down for the more positive value beta, and then set the tuple to be alpha gamma, alpha beta. So we swap these around using the positive value for the negative side, because alpha itself is negative. And then if alpha is equal to 0, then I'm not sure what I want to do. The tuple, I guess the positive should be 0, because like the positive, but should the negative side also be 0? Maybe not. don't think so. Oh, I don't know. Wait, let me try an example. So like, if I had a 0, I gotta do a fresh example. So like, if I have a 0, let's say like I had a 2 here, and a 3 here, a -1 here, and like a 0 here, maybe a 0 here as well. 2, 1, -2, maybe I'll say -1, 1. So I think the best path would be this, right? Because you have like negative makes +2, then 6, 12, 24, right? So that'll be like your best. So over here, like the best positive thing I can make is nothing. I'll do this in blue. The best positive thing I can make is nothing. Most negative thing I can make is -2. Most positive thing I can make is 0. The most negative thing I can make, I don't know if I should say 0 as well or none. I think I'll say none. Then here, the most positive thing I can make is 0. The most negative thing I can make is none. I can't make anything negative. Here, the most positive thing I can make is, so there's nothing I can make here. I can make a 0. Most negative thing I can make is a -6. But if I had set this to 0, then this would have said 0, you know? But I think I would prefer to say -6 because I want to be able to say, look, the most positive thing I can make is 12. If I had 0 over here, then this wouldn't realize it could make a 12, you know? I don't know. So I think it's good not to like, I think the negative part of the tuple has to sort of play in the spirit of really trying to make things negative. Like you want to make things really negative with the intention of, if another negative number comes by, you can multiply by that negative and make a nice positive number, you know? So that -6 really wants to carry through, which I think won't happen if, you know. So set it to 0 and none, I think. And then if I try something similar over here, the most positive thing I can make is 0. The most negative, well, I say positive. I guess it's like more, I guess the tuple is non-negative negative rather than positive negative. The most non-negative thing I can make is 0. The most negative thing I can make is none. -1, the most positive thing I can make is 0. The most negative thing I can make, no, the most positive thing I can make is 6, isn't it? The most negative thing I can make, is it possible to make a negative thing? No, because otherwise I go 0, which is, we're saying is non-negative. And then I can go -3, and then a -1 at the end. So I think this accurately tracks the fact that I cannot make a negative argument. I can't make a negative thing. But if I said 0 over here, then it would say, oh, the most negative thing I make is 0, which isn't, you know, it's a bit 50-50. I think this will work. What's the most, oh, I didn't say it. What's the most negative thing I can make? 12 was here. Then none. I can't make a negative thing. -6, yeah, because I'll always hit the -1 at the end. And then 2, what's the most positive thing I can make? 12. Oh, it didn't work. Wait. I was supposed to get 24, wasn't I? Oh, wait, this is meant to say 12, isn't it? Sorry. No, this will say 24. And the most negative thing I can make is none. And then return this. Or return -1 if it doesn't exist. Okay, we will see if this works. I'm not 100% confident, but it seems like it could work. Proving this would be interesting, but I probably won't. Okay, so we're going to begin by allocating all the correct space for our DP array. So DP equals an array. Oh, maybe I'll get the dimensions first. M equals the length of grid. N equals the length of grid 0. And I'm assuming the grid has at least one row. Yep. So we're going to make the DP array. It's going to be a bunch of tuples. We'll just allocate the space first. 4 in range n, that many columns, and then this many rows. Very good. So we have that. And then, so the order of dp, it's going to be like this, and this, and this, this, this. So I always want to make sure, just remember, I always want to make sure that I have the bottom thing ready and the right thing ready. So if I go in this order of like, this is my base case, maybe I can fill in, maybe I'll do the bottom row like separately. So if, bottom row is equal to m minus 1, and for col in range n minus 1 down to z negative 1 with the decrement of negative 1, what do I want to do? I want to say, well, first things first, I should say dp at m row m minus 1 col n minus 1 if I've got to do my base case. If grid at m minus 1 n minus 1 is greater than or equal to 0, then the dp there is equal to the grid value, none, else the dp value is none, and then the grid value. So that's the base case. And then I don't have to do n minus 1, I can do n minus 2. So I just got to make sure that that makes sense, but I think that should work. For col, so I'll just write a possible edge case is if you have one column. I don't think this will be a problem, but this kind of thing for one row. So for each sort of subsequent column, I'm doing like the rest of these in the bottom row. The only neighbor you're able to look at is equal to dp, I guess neighbor positive, neighbor negative is equal to dp at the same row, but at the column next to you. So to the right of you, that is. So if the place I'm at, which is bottom row column, if it's greater than 0, then I've got to do this thing. If it's greater than 0, take the beta value, which is the positive value. If I multiply by none, does that give me none? If I multiply by none in Python, does that return none, or is that an error? It probably is an error, but yeah, fair enough. If neighbors is, if neighbors we'll say best positive is none. If neighbors, then best positive is equal to our alpha value times the neighbor positive. Best negative is equal to none. If neighbor negative, then if neighbor negative is not none, then best negative is equal to alpha times our gamma. This feels a bit silly, but anyway, it's alright. So we have I think I need to put these in the outer scope. else, so if it's else elif grid bot row col is strictly less than 0, then yeah, if negative, then the best positive is equal to this guy, alpha times gamma. If positive, then the best negative is equal to alpha times beta. Else, if it's 0, then we say the best positive is equal to 0, the best negative is equal to none. And then the tuple we make, which would be, what's the tuple? The tuple we make, so grid at the bottom row at the current call would be the best positive and the best negative. Okay, so that's just the bottom row. So then I was thinking I'd do a second for, like, I'll do the double for loop with all the other cases separately, but I might be able to just do it all in one go because, let me think about this. I'm going row by row from bottom to top, so for row in range, m-1 down to -1, -1. For col in range that, so instead of saying bottom row, I'll just say row all the time. I just gotta be really careful because right now I'm only considering the right neighbor, but if row is, you know, less than m, if we're not at the bottom row, then I gotta be careful. Neighbor position, neighbor positive. Okay, here's what I'll do. So I will only check the right person first, and then if row is less than the bottom row, m-1, then neighbor positive is the maximum between what I currently have in the right neighbor, or it could also be dp same column but one row down, looking at the 0 index, you know, and then neighbor negative is the minimum between what I have as the neighbor negative currently, looking at the right neighbor, and dp looking at the row +1 col, but looking at index 1, looking at the beneath row thing. Now, the other thing I can do is if row is equal to m-1 and col is equal to n-1, that is, we are at the bottom right, then I've already done that case, so I can just continue. Otherwise, yeah, do all this, look at the right neighbor, also compare it with the bottom neighbor if a bottom neighbor exists, and it will exist if we aren't on the bottom row. That's why I do that. Best positive is none, best negative is none. If a neighbor positive exists, that is, there is a way to get a positive value somehow, then best positive is that, best negative is that. Elif, this one is, if it's negative, if alpha is negative, then get the gamma value and multiply it by alpha to make the best positive, because gamma is negative, as is alpha, and alpha is negative and beta is positive to make the best negative. Otherwise, do this. I hope this works. I'm not really sure. And then basically, if dp 0, 0, 0, then return dp 0, 0, 0. Mod So I'm really leveraging the Python, max like infinite precision thing. Mod equals 10 to the power of 9 plus 7. I don't know if I really back this at all. Otherwise return -1, because this indicates that there's no way of making a positive product. Okay. Is it correct? Probably not. But I think the idea makes sense. It's just, I don't know if it's the zeros. The zeros are really tripping me out. I feel like if there were no zeros, then I think this would work. Like, I think I could be comfortable. But if there's a 0, then the question becomes, am I sort of always giving the best option? Am I always carrying the best option forward? Because I want to carry that zero information. But I also want to carry like the negative information. Like, what if the 0 is here? Let's say that we have a 0 in the middle. Hang on, I could just submit this and see if it works, but I just want to check. So if I have, do it in red. If I have a 0 like this, I'll do a 4x4 just so like, let's say I have like a 0 here, then like a 1, 3, 2, -1, -2 at the end, 3, -2, maybe another 0 over here or something. 1, 2, 1, 1, 1, 1, 1, right? So I've like very specifically rigged it so that this is my best path, because you got 2 negatives here and here, so that will become positive. That's fine. In terms of the DP, this will look like none -2 by the base case. This will look like none also -2. This will look like 4 none, right? Because if neighbor positive, otherwise I'll just use best negative is none. Yeah. So grid was negative. If neighbor positive, it's there isn't. Wait. Yeah, I think this will be fine, right? Ooh, you know what could be the problem though? What happens if... Okay, wait. If neighbor positive is none, and then I try this, will this return an error? Because this could be, one of these could be none. In which case, if I do a max and min, there could be problems there, right? Do I have to be more specific? Like, if this and not this, then this is equal to this. Elif not this, no, elif this and this, then do this. And then similarly, if the bottom is good and not neighbor negative, there was no neighbor negative from the right neighbor, then neighbor negative, wow, the rain is crazy, neighbor negative is equal to this. Elif, if they're both existing, and this is also good, then this. So just to clarify once again, so if we're in a position where we have a below neighbor on top as well as having the right neighbor, then if looking for the best positive results, if there was no neighbor positive in the right neighbor, but there is one in the bottom neighbor, then set neighbor positive to be at bottom neighbor. But if they do both exist, then we have to do a maximum. And if, obviously if DP row, if this doesn't exist and this one does, then it's as if this ran and this didn't run. Like, that's fine. It's like the else, I don't have to explicitly write anything for the else. And then the same kind of idea here. Okay. Yeah, so like I said, I think this will carry through no problem. And then from here, the best positive I can make is 8. The best negative I can make is none, because going like this is going to make a positive value only. Here, ooh, I didn't think of this. This guy has no right neighbor. So what I should really do is say neighbor positive is none, neighbor negative is none. If if column is not in the rightmost column, then do this. And then if, yeah, okay. So this will only look at the bottom now, because yeah, and this is already set to none, so it should be fine. Okay, so we look at the bottom. The most positive thing I can make is none. The most negative thing I can make is -6. I look over here. The most positive thing I can make is none. The most negative thing I can make is -6, going this way. Okay, and then I just set this to 0, none. The most positive thing I can make is 0. The most negative thing I can't really make a negative thing. The most positive thing I can make is 16. The most negative thing I can make is none. I can't make a negative thing going anywhere. Most positive thing I can make is none. Negative is -6. Most positive is 0 and none. Most positive thing I can make is 0. Most negative thing I can make is none. I can't make a negative thing, yeah. Most positive thing I can make is 0. Yeah, because either way I go, I'll get a 0. Most positive thing I can make is 48, and then this will be like another 48. Okay, I think it makes sense. I don't know. Proving this would be, I think, a bit involved. Whoops. Not is none. Equals none. Proving this would be a little bit involved. I think just like making sure like, oh, whoops. Well, let me print the DP values. I'll import. Let's just see if it went wrong or if the logic is wrong, What's the example? 1, -2, 1, 1, -2. Oh, it's the same one, isn't it? Well, that's unfortunate. I mean, I'm handling the data really weirdly, so I could have made a mistake very easily, but I am a little bit concerned that the logic is just straight out wrong, which would be more annoying. Okay, so this is my DP. So originally everything is none. If I play this through, and then I'll just check this. So this should be 1, none. This should be none, -4. This should be none, -12. This should be 1, none. This should be 8, -2. This should be 8, -12, going down this way. And then this should be 1, none. This should be -16 over here, +4 over here. This should be 8 and -16. So I should have gotten 8. Well, that's unfortunate. Okay, so at least for this example, the algorithm should have worked, but my coding is wrong. That's good. Sounds about right. Should I be printing like 1, none. So the only thing that worked is the base case, the thing I did separately. I might have made an error in terms of, like, if this is the case, continue. I didn't say break, I said continue. Good. And then this is none, this is none. If col is less than n minus 1, like this should have ran for sure, because like this would have been n minus 2 at the very first case. I look at neighbor positive, neighbor negative, and I unwrap this. So this should have been 1 and 0, 1 and none, sorry, initially. If rho is less than negative 1, so that, sorry, if the rho is less than n minus 1, so this shouldn't have run in the very first case, so I'll just ignore it for now. Best positive is none, best negative is none. If grid at, oh wait, no, I called it row and column, sorry. If grid at row and column is greater than 0, it was not, right? It was negative 4. Else if it's less than 0, it was, right? I'm looking at the negative 4. If neighbor negative was none, so this wouldn't have run. If neighbor positive, which is a thing, then this should have run. Best negative is, you know, alpha times the neighbor positive, which should have been 1. So I should have gotten my negative 4. And then I should have done this. What? As in, like, obviously tuples are, what they called? Immutable. So I can't, like, edit the tuple, but I can just replace it, can't I? Okay, I guess I'll do some prints. So print current position is equal to row column. Found tuple is equal to this thing. Let's just see what happens. Yeah, what? Current position is 2, 1. Ah, I said grid, not DP. Sorry. That's my bad. Obviously. No. Alright, this might have been more problematic. How come it didn't do the... I thought pretty print would always put different rows on different lines, but I guess not. Current position is 1, 0. Found the tuple at 0, none. Current position is 0, 1. So this did... Okay, so maybe my logic didn't work. 0... Okay, so none... So it's the last example. 1, 3, 0 minus 4. 1, 3, 0 minus 4. So my DP would be none, negative 4, be 0, none. Again, this should have given me 0. Okay, so the 0 case is failing, but this would be none, negative 12, and this would have been negative 12 and 0. I should have returned 0 for sure. I don't know why I returned negative 1. So the 0 case failed. Best position is like... At position, this is position 1, 0. Yeah, so the tuple is correct. It knows it's 0, 9. So it would have done that correctly, I think. But why did it say none here? It shouldn't have said 0. Current position is 0, 0. So it must have failed the row thing. If DP at row plus 1 col 0, like this should have ran, right? Why did this fail? If DP row plus 1 column 0, DP row plus 1 refers to the guy beneath you. And then same column, and then the first, like the 0th index. That's, oh, because it's 0. Is not none. I forgot about that. I have to be really explicit. Is not none, and neighbor position is not none. Oh man, okay. This is gonna get really ugly really fast. But I think I have to. So I have to explicitly be like, if neighbor position is not none, because things can be 0. Just to clarify, what was happening is, if neighbor position checks a few, like if you just say is neighbor position, it will return false if neighbor position is 0, you know, like 0 returns false. So that's what was happening there. Did I do it? Is there anything else? My eyeballs. I think everything else is fine. Oh. What? Okay, now I'm a bit more confused. Wait, what? It gave 0. Oh, probably the same thing. Yeah. Alright, I think it works, but I'm not really sure. I don't have 100% proof in my mind, but I will submit. We'll see. Oh. We got close. Alright, so this might genuinely be an issue with the logic, because again, it's the zeros, man. Alright, so let's see. So we got -1, 3, 0. -1, 3, and 0. 3, -2, 3. Whoops. 3, -2, 3. -1, 1, 1, -4. So the DP in turn would be the same size, originally set to all none. So you have none, -4, you have none, -4, you have 4 and none, right? Because you can only make a +4 here, you can't make a negative number. You have none, -12, you can't make a positive number here. You can make, oh no, you can, sorry. You can only make a positive number, so you can make 24 over here, but you can't make a negative number because you would hit that second negative by the end. Positive, you can make, what, 12, 72? Is that right? 3 times 12, carry the 1. So yeah. And then negative would be none because you can't make a negative number because you'll always hit 2 negatives. That tracks. Then this would be 0 and none. Yeah, it doesn't carry through because 3, it would say that the best thing it can make is 12, also 72, right? But then the -1 means, the -1 means you would say you can't make anything, and then you can't make anything, and you can only make a -72. That's what the -1 would see. So it doesn't carry through. I didn't think of that. So is it better to have a 0? Is it better to somehow permeate the zeros across? Like, but is it only the zeros? Like, what if this was like a 2? You know? Then this would be like none, or like a -2, let's say. So this would be like 24 over here. Oh, no, not -2. -1, we'll say -1. Let's say this is -1. then the most positive thing I can make is 12. The most negative thing I can make, there's no negative thing I can make, so none. And then it would take the 72 over here. It would take, like, from here, it would take the 70, it would take 24 and say, hey, the best positive thing I can make is 72. The most negative thing I can make, there's no negative thing I can make, because I can't make anything negative, so it would say 72, none. And then I had the same issue. It would be negative, like, what's the most positive thing I can make? I can't make anything positive because I only see 72 and 72. I don't realize that I can see, like I could go, I don't see this path of going across all the way. I don't see this, or this, actually this doesn't work because it'll be negative. Okay, so 0, okay. But my point is, it's not just about zeros. I think it's like, my solution is too short-sighted to realize that there is other options. It only really tries, this and this, and if these guys claim that they're not able to make negative numbers in this case, then it will just give up, which means the none here can't be none. I need to do better to not just make this none straight away. Like, I have to figure out what to say in this position. Because the reason why it fails is because it never realizes there's a negative number that can be made. So should this maybe? So let's take this back to 0. Let's say this is 0. And let's say this is 0. Should I make this 0? I'm a bit concerned about making this a 0. But maybe it does work. What's the most negative number I can make? I can't make a negative, but I can make a 0 here. And then what's the most positive number I can make? Well, I take, maybe it does work. Okay. So the tuple isn't defined. So the tuple is defined as the first the biggest non-negative number I can make, and then the smallest non-positive number. Smallest meaning the most negative. So maybe that's better. So this should be 0, 0. I can't believe if that's the only change, then I can't believe I got through 156 cases without that tripping out. I think I do like it more. I think the reason why I was a bit iffy with the previous was because this was asymmetrical. Like the fact that the 0 arbitrarily, I chose the first thing to store the 0 and the second one to store a none. Like it felt a bit like random and not as well structured. This one intuitively feels like it makes a bit more sense because of this particular test case where like what you're basically asking is what is the most, like when you're checking the most negative, when you're trying to fill in this part of the tuple, you're asking what is the most negative thing I can find. So I have a 3, so I'm looking for the negative side, and none, if I see a none, that literally means it is impossible to make a non-positive value. And that's true in this case because I can't make a non-positive value here or here. But here it's saying, well, the most non-positive value I can make is 0. Maybe I should just check something. So if this DP is not none, then return that. If DP at 0, 0, 1 is equal to 0, I'm not sure if I have to add this, but then I'll just return 0 just in case, because maybe somehow this will be none, but this will say 0, in which case it's possible to make it 0 somehow. I'm not sure, but I just as a safety check, I'll just do that. And then otherwise, we really are confident that we can only make negative numbers. I don't know if this will work because the fact that I've passed 156 cases, now I'm worried that somehow something else will fail because I changed this from none to 0. If I take one of my previous examples, what if I say, this is a 0, this is a 0, in which case the most negative thing I can make, or the most non-positive thing I can make is a 0. This would still check the 16 and then be like, what's the most negative thing I can make? 0. Maybe it's fine. I think it might be fine. Okay, nice. Okay, yeah. I think, I actually think now with this structure, I think it actually is much more comfortable to prove this because your definition, you define your tuple, like the output of your subproblem Q ends up being what is the most positive non-negative number you can make, right? And then the second part is like the second position in the tuple. So the tuple looks like this, right? The first position is the most positive non-negative number you can make, non-negative product. And then the second part is the most negative non-positive number you can make. And then the value of none really means it is impossible to make a non-positive, a non-negative slash non-positive number, depending on which position you're referring to. And then from there, like I think if that property holds throughout the entire problem, and I think it does, if that property holds, because it holds for the base case, and then like through the way you traverse through the grid, I think you could prove it. You can prove that, well, the only reason why you would have a none here is because there is the only reason you would have a none here is because there is literally no non-negative number you can make. And in fact, based on that, I think I can delete this safely, because if the most non-negative number you could make was a 0, then it would show up here in the top left as a 0, in that first position of the tuple. So I reckon if I do that, I think it's still safe. Oh, I lied. I don't need to import this. Well, that was a big spiel of nothing. What was... I'm curious now. Why did that fail? Am I wrong? So like, because I thought the DP would mean that the 0 would carry across into the first position as well, like into the 0th index. It wouldn't have to look at the second index. -1, 1, -2, -1, -1, 1, -2, -1. And then what? 3, -3, -2, 0. So the DP, in turn, would be 0, 0, and then the most positive thing I can make is 0, the most negative thing I can make is 0. Same here. Same thing here. Most positive thing I can make is a 0, the most negative thing I can make is a 0. Same... Wait, how did this fail? Wait, what? There wasn't even any none in here. How did it get -1? I'm confused. What did I do? Like, I made this change. All I did was, just to clarify, all I did was that, right? That's the only thing I deleted. Let me pretty print DP at this point. Because my code, okay, so even though I did this, I didn't adjust my code to look for both. Okay. So basically, even though I conceptually wanted to do this, I didn't actually code it to do that. Let me do that, because it's important. Like, obviously, I guess it's like a cheap hack to be able to say, like, whatever I did before. This works, I guess, but it's better in terms of the structure if I actually do this properly. So, you know what it was, actually? The important thing was... So yeah, it's this. If the grid at n-1 is less than 0, then else the this is like where the problem initially arises. This thing should be equal to 0, 0. So the base case was wrong actually. And then get rid of this. Sorry. So the base case failed, which is why. So now if I print dp now, the 0 should have carried across, I think. Damn it, I'm dumb. It returned. There you go. So yeah, basically there was no 0 to carry before. Now there is. All right, I think this should work. This is the better answer, even though it's very little changes, and time-wise nothing changed. But like it is a better answer. It actually carries the meaning of the subproblem across the array. Like the definition of each element in the DP array is more accurately reflected in the DP by doing it like this. So I was close. The only thing was, yeah, first of all, making it 0, 0 instead of 0, none, and then adjusting the base case accordingly. So what, one fail before I got it, and then that. But yeah, that's not bad. What did the other people do? Because there are some quicker things. How do I'm on this site way too much not to know how to do this. Okay, there we go. What are like the quicker things? Okay, at least no one wrote like a 2-line solution, you know? Previous row is equal to infinity negative. Oh, this is, yeah, so similar idea. Like they used a list, I used a tuple, because I thought using a tuple would, in my mind, would just make it easier to differentiate between like what's a list, what's a tuple. I thought list and list and list was a bit annoying, so I thought I'd do tuples, but otherwise same idea, except they use infinity and negative infinity. I just use none to indicate that you couldn't make anything for this and this. If this is less than 0, then this previous row, I think it's the same logic. Previous row 0, 1 is equal to grid 0, 0. It's a bit long. I don't really have the brain power for this. I think it is similar. Like it definitely looks like a DP thing. Cool. Topics, I assume, says DP. There it is. Staff, yeah. If someone could make me their staff, I'd appreciate it. Yeah. Oh, they just say highest and lowest. They didn't even bother with the negative thing. But anyway, what are people saying? A nightmare for beginners. Yeah, I don't know. It'd be pretty. I think the only reason why I even had an idea was because of that other problem, the number of ways problem from top left to bottom right. So it's definitely one of those things where you want to have done the problems before you did this one. All right, well, that was good.